Solving a quadratic equation using the square root property. In these examples, we are going to try to isolate the item that is being squared so that we can take the square root of both sides of the equation. Before we take the square root, we have to move anything away from the squared term that might be making it more complicated. So in the first example, I'm going to start by dividing both sides by 3. I'll end up with x minus 4 squared equals 5. The next thing that I'll do is take the square root of both sides of this equation. When I have something that's squared and then I take the square root of it, those two operations cancel one another out because they're opposite operations. And so I'll end up with just an x minus 4 overall. Now on the other side, when I take the square root of a number like this, and this happens only when we're solving equations, we are expecting to get two solutions because our overall equation here was squared. And so I have to think about the fact that there could be a positive or a negative answer. And so I'm going to write this as plus or minus the square root of 5. Now, just making a point over here, when I'm doing a calculation, if I had some numbers that I was putting together and then I wanted to maybe add the square root of 5, when I don't have variables, we use only what's called the principal square root, and the square root of 5 would stay as positive. But when we're solving equations, that's when we put that potential plus or minus into our work. All right, for our next step, what we're going to do is we're going to add 4 to both sides of this equation. And so I'm going to have x equals 4 plus or minus the square root of 5. This is my final answer in a compressed form. What this means is that x equals 4 plus the square root of 5, or x equals 4 minus the square root of 5. For our second example, we can take the square root of both sides directly because we don't have anything that is complicating the left-hand side here. So I'll take the square root of both sides. The square and the square root are going to cancel each other out. And so I'll just have 2x plus 1 on the left-hand side. And then on the right-hand side, I know that the square root of 9 is 3, but again, I need to put a plus or a minus 3. All right, now we will subtract 1 from both sides. 2x equals negative 1 plus or minus 3. And then we'll divide both sides by 2. X equals negative 1 plus or minus 3 over 2. All right, let's simplify these answers here. All right, option 1 is, I'm going to go up here. X equals negative 1 plus 3 divided by 2, or option 2 is x equals negative 1 minus 3 over 2. For the first one, we're getting x equals 2 over 2, or x equals 1. And for the second one, we're getting x equals negative 4 over 2, or x equals negative 2. Right, I'm going to go over to Desmos and graph this original and see how our answers match up with what we got. Okay, I've moved over to Desmos so we can take a look at those answers that we just got. The first equation that we were working with was this one up here. One thing you want to take note of is when you go to Desmos, you don't want to put an equal sign in what you're typing in, because what Desmos does is it solves the answer and then it just puts these two lines here that are going over what the solutions are. If we want to see the graph, we need to move everything to the left-hand side so that we're essentially setting this whole thing equal to 0. Because when something equals 0, that is letting us know where it crosses the x-axis. And so what I've turned on here, this blue graph, you can see I moved that 15 over to the left-hand side and it showed up as a negative 15. Desmos automatically knows to graph y equals whatever you've typed in, and then it also knows to automatically have it be set to 0. So the two answers we got were 4 plus the square root of 5 and 4 minus the square root of 5. If I click here on that x-intercept, I can see that 1.7 is matching up with the 4 minus square root 5, and then the 6.2 is matching up with the 4 plus square root 5. All right, let's go to our next example. The second example we had was this equation here. Again, I've moved that 9 over to the left-hand side and it shows up as a negative. And so this is the graph that we want to look at. The solutions we got were x equals 1, and we can see that that's one of our intercepts. And the other one was x equals negative 2.